this problem is really cool. It has us solve for something that we normally wouldn't have to solve for this type of variable. So here Susie buys a machine that costs $1,000 and it makes her $200 a year. And this is the interest rate we get to assume. And the question wants to know basically how many years do we have to wait until the present value of the profits that we generate is equal to the original cost of the machine. Basically, how long does it take the machine to pay itself off? And so what we're going to be using here is only equation 1, the equation with the integral. And so specifically, this 1,000, we're going to think of this as what we want our present value of our profits to be. This is our S of t here. And finally, we have our R. But the thing we don't know is the m, and that's something we may not have ever solved for before. So let's just write out the equation to see what we have. Right now, we know that 1,000 is equal to the integral from 0 to m of 200 e to the negative 0.05 t dt. All right, and so to solve for this, I'm first going to realize that since this is 200 as a constant, I can pull it out of the integral. So that would be 200 integral 0 to m e to the negative 0.05 t dt. And now I can divide each side by 200. So I'll just have 5 is equal to the integral from 0 to m of e to the negative 0.05 t dt. And so this is the point, and in most of the other problems that we've done, probably would have been putting things into a calculator. But here we're not able to because this variable is not known. And just a word of warning that this is probably the way it's going to be on the final a lot to kind of force you to not use your calculator. So how do we do this? Well, we have to remember the formula that the integral of e to the kt is 1 over k e to the kt. So this integral is 1 over negative 0.05 e to the negative 0.05 t, right? And so at this point, I've done all the integrals. If I was going to try to do something in my calculator, I would not use an FNINT. What I would do, and the way we denote this is we put a vertical bar here and we write t equals m, t equals 0. What I would do is I would plug m into this, and I would plug 0 into this, and I would take the difference. And that quantity is actually equal to what this original integral is. So let me write this out a little bit more, kind of re-emphasize that point. So I plug in capital M first, and now I'm going to plug in 0, and I'm taking the difference of these two things. So 1 divided by 0.05 e to the negative 0.05 times 0. All right, so this thing I have in parentheses here, this quantity, I could type this into my well, if this m were an actual value, I could type it into my calculator. But this quantity in parentheses is the same value as this quantity. And so since I've actually done it explicitly like this, I'm going to be able to solve for m. Now, how do I do that? Actually, first I'm going to notice that this whole thing here, this is really e to the 0, so that's 1. I can add that over to the other side, so I'll have 5 plus 1 divided by negative 0.05. And then this thing is going to be equal to 1 divided by negative 0.05 e to the negative 0.05 times m. So notice you could have multiplied some things at different points if you're wondering about that. But the way you could finish this one off is you're going to have to use logs. And to use logs, you want to get the e by itself first. So we're going to multiply by that, by the reciprocal of this. So we'll do negative 0.05 times 5 times just what was on the other side. And now this side, I'm just left with my e. So now taking the ln, we'll drop that down. So I'll have the ln of negative 0.05 5 plus 1 divided by negative 0.05 equals negative 0.05 times m. Now dividing each side by negative 0.05 will give me my value of m in this case, which if you actually went and typed that into your calculator, you would get m is equal to about, let's see where that is, about 5.75 years. And you should always go back and check, does this make intuitive sense? All right, 5.75 years of $200. Yeah, that's in the range of $1,000, so that makes sense. Okay, but just to reiterate, the message to this problem was to use the formula we knew and recognize that m was the thing we didn't know. And when this bound on the integral is something we don't know, we're generally just going to need to do the integral by ourselves. And so doing that integral gets you this, and then it was all a matter of just using logs to solve the problem.